Hello. Hello. Are we live? Okay, cool. Hi. Thank you everyone for coming. This is our inaugural Fastly Devs live stream. So you are getting in on the ground floor of what is going to be some of the best content about Fastly on YouTube. Lucky you. My name is Journey, and I'm here with Kailan today. We are both software engineers on Fastly's developer relations team. And today we are going to learn how to build a queue on the edge. So first, I want to talk a little bit about Fastly. What do we do? What is Fastly? We started out as a CDN. We started putting our fingers into security. And now we are an edge compute platform. We have an edge compute platform called Compute at Edge. So we provide edge computing with the goal to speed up and secure the internet. And we run C@E with WebAssembly natively. So you can use any language you want as long as it compiles down to WebAssembly. And we have some customers that you've probably heard of, like Epic Games, the New York Times, Reddit, Ticketmaster, which companies like Ticketmaster need queues. So it's kind of fitting that we are building a queue today. And yeah, thank you so much for being here. I'm going to hand it over to Kailan to talk about what we do as the developer relations team at Fastly.
Thanks, Jenny. So yeah, as mentioned, we're on the developer relations team, and we're part of the wider developer experience org within Fastly. And what we're responsible for is a lot of content like the live stream you're watching now, but also content like developer documentation. If you've ever seen the Fastly Developer Hub, we're responsible for that, as well as the tooling that's used to work with our platforms like Computer Edge. So we maintain Fiddle. Fastly Fiddle is a tool for experimenting with code at the edge. And we also maintain the CLI, which is the main method that you would use for interacting with Computer Edge. With the recent, well, I say recent, it's been almost a year now, with our acquisition of Glitch, we've joined hand in hand with their team, and we work hard with them on all of the kind of community relations type things. One of them being Fast Forward, which is our open source program where we're sponsoring a bunch of companies who are doing some fantastic work. We also organize community meetups and events, and this is something that we're really keen to grow this year. So if you have any interest in events, we'll definitely be talking about that. So you should really subscribe to our channel and follow us on Twitter as well. I've actually just stolen your work there, Journey, because you were going to talk about that.
Oh yeah. So yeah, our Twitters are down here. There's also the Fastly Devs Twitter account in the corner. You can find our blog posts on dev.to/Fastly. I'll post them in the chat right now. And you can find our work on the Developer Hub, which is where you can find a ton of information about how to build what you want to build on the edge with Fastly. And it's also where you'll find our queuing solution starter kit, which we're going to expand upon today. So I'll also post a link to the Developer Hub in chat for
We
your
will
viewing
be
pleasure.
keeping an eye on the chat. So if you have any questions or thoughts during the stream, please pop them in the chat because we'd love to interact with everyone watching today. Okay, Jenny, what are we actually going to be doing today?
We're going to build a virtual queue. So a virtual queue is a queue that lines up a group of users and gatekeeps them from accessing a site until the people before them have finished whatever it is that they need to do. So you might have encountered this on the web, trying to buy Coachella tickets or get that new pair of Nikes. So that way it prevents the site from being overloaded with way too much traffic by ordering the users in a neat little line. So yeah, those are some examples of virtual queues. Fun fact, you can also have a virtual queue off of the web. The old FastPass system at Disneyland is kind of an example of a virtual queue. It's where you like take a ticket and you come back later to get back on your ride. So it's kind of like the ticket is holding your space in line for you. So lots of uses for virtual queues. So what are we going to need to build our queue today, Kailan? What are our ingredients?
We've got a few ingredients for this tasty recipe. The first of which is our edge computing platform, Computer Edge. And the reason that we're using the edge for this is because we want to shield our backends from any unwanted traffic. Typically, if you have a queue system in place, it's because you're trying to protect your backend and you're expecting a ton of traffic. So by moving this queue logic to the edge, you don't have to worry about your backend getting overwhelmed with requests just to load the queue page. And it can focus on the actual business logic that is being protected. The benefit of using Computer Edge over another Edge cloud platform is that we run all of the programs using a WebAssembly engine. And a benefit of this is that you can write your code for Computer Edge in any language that you like, provided that there is support for it in WebAssembly. And this has proven really popular with our customers because we can offer solutions for every language that they like to use. And in fact, this queue solution that we're working on today, although it is written in JavaScript, we also have a completely identical version in Rust as well. So if that's more up your street, then check out the Fastly Developer Hub, where you can work with those starters. Another ingredient we're working with today is the actual starter kit that we've already shipped. We have a queuing solution ready for Computer Edge. It's perhaps not production ready in that you need to customize it and make it work for your use case, but it really helps to get started with a solution like this. And it's free to use this starter kit as long as you have a Computer Edge account. You don't need to pay any extra, it's not a product. And because it's just a starter kit, which is a GitHub repository, you can completely customize the behavior. And it's really just it can be a turnkey solution or it can be a completely customized use case. And to power this queue, we actually need to keep track of a few pieces of state, one of which is the length of the queue, and another of which is how many people have made it through the queue already. Unfortunately, Computer Edge doesn't yet support atomically incrementable counters, and this is something that's really integral to this design. So we're actually using a third-party service to store the data, and we're using Upstash, which is a Redis host. If you haven't used Redis before, it's a really simple key value store, but it has a lot of power because of its various data structures. And Computer Edge needs to be able to talk to this in some way. And Upstash is perfect for that because Upstash provides an HTTP API where we can talk to their Redis instances from Computer Edge really easily. And an even better thing is that they actually provide a JavaScript library which supports Computer Edge. So we can just pull in their Upstash Redis dependency from npm and use it in a Computer Edge project, and it would work as we expect. The final ingredient is actually our JavaScript support within Computer Edge. So we compile SpiderMonkey, the JavaScript engine used by Firefox, down to WebAssembly, and we run that within our servers across the world. And that allows all of our customers to run their code without needing to worry about actually making it compatible with WebAssembly too much. Okay, I guess let's jump into building. Are you ready, Journey?
I'm ready.
Fantastic. Okay, so the very first stage is that actually we want to pull down this starter kit. We'll assume for the purposes of this that you have the Fastly CLI installed anyway. This is really simple to install with Homebrew or your preferred package manager if you're on a different operating system. Let's go into the terminal and we'll initialize a project. We're going to be asked a few questions, so we'll just call it my queue. And it's that straightforward to initialize a new Computer Edge project. So let's hop into the code.
Let's do it.
My computer appears to be struggling heavily. We'll get there. Okay, fantastic. And let's zoom this in a bit so that everyone can see. Okay, great. So If you've worked with JavaScript before, I'm sure this doesn't look too daunting. The main entry point for a computer edge JavaScript application is typically a function that takes in an event. And that event is a fetch event. And if you're familiar with the web workers specification, this is actually a standard data structure that is passed in. And from this event, you can gather information about the incoming request, such as the URL, method, and you can also get information about the client. That allows you to look up their geolocation information or have operations based on their IP address. I'm not going to walk through the entire starter kit's code because we would be here all day, but I will give you a brief run through of how it works. So very first thing we do is fetch some config from an edge dictionary. An edge dictionary is our way of configuring an application dynamically rather than hard coding parameters. And these are soon being replaced by config stores, but as this starter is still using a previous version of the SDK, it is a dictionary. The difference between a dictionary and a config store is that a dictionary is unique to one service, whereas a config store, you can share the data between multiple services on your account.
You can have a lot of queues.
A lot of queues, and you can have a lot of queues across multiple different services, which is, yeah, absolutely possible. The next thing we need to do is initialize upstash. So we've created this utility file here that allows us to initialize the upstash store. This Redis type comes from the upstash library, which we've just imported up here. And it's worth noting that you need to import the Fastly specific version because there's an additional parameter that needs to be passed into Redis, which is the name of the backend that you're sending the request to. If you're not familiar with how Fastly works, we require you to define a backend to send a request to it. And this is not only for security reasons, but also allows us to improve the performance of our customers' applications because we can pull connections to backends and reuse them across multiple requests. So by defining a backend in your Fastly service, which I'll go through later when we finally deploy this, you're able to get all of these benefits. And then we just have a few functions here for manipulating the data that we have in the store. So we can fetch the current queue cursor, which is how many people have been let in so far. We can increment the queue cursor by a given amount, which would let in a certain amount of people. And we also get the queue length, which is how many people have joined the queue in total. And using the queue length and the current queue cursor, we can determine how many people are in front of a given user, which is great for the user experience. And finally, also a function to increment the length of the queue when a new user joins. We won't discuss this for now, but if we have some time at the end of the stream, I would love to talk about also how we've managed to make the queue entry automatic. And this is a big part of what Journie and I will be implementing later on. So once we've initialized the store, we fetch a cookie from the user's browser. And this cookie is a signed token, a JSON web token, and it contains their current position in the queue, as well as the current date and time. It's okay to store this in the browser because we know that the user can't manipulate it, because if they do, we'll know that the token is no longer signed with our public key. It's very easy to verify, and this is a big benefit of JSON web tokens because it allows you to move some of the state to the client while still knowing that that state is the correct state. So
no cutting.
No cutting in queue, exactly.
Queue.
It wouldn't be much of a queue if you could just manipulate your cookie to say, I'm in position 0. So yeah, we do absolutely sign the data that we send to the client. And we can do that using the standard JavaScript JEWS library. That's fully supported on Computer Edge. So we pass the cookie, if it exists, to extract the payload. And the payload is a JSON object that contains the user's current position in the queue. We also need to run a separate call just to verify that the signature is correct. And we verify it against the JWT secret from the dictionary that we pulled earlier. So we now know that if the user has already got a position, then it will be stored within this payload variable. So at this point, we can now fetch the current queue cursor from Redis. And we actually need this piece of information for every single request that goes through our service, because we need to know if the request has been allowed or denied. And for this reason, we would recommend that in a production implementation that you would cache this. You can cache this by passing custom parameters to our fetch method. However, the upstash library does not expose this. So in a production scenario, we would expect that you would swap out this store with your own implementation. Luckily, it's relatively simple, so you know, that's not a big load. So once we have the current queue cursor, which will tell us how far into the queue the user will need to be in order to be allowed in, we calculate the current visitor position. So if the visitor position has been provided in the token that we just decoded, and the token is valid, then we can just set the position to the position provided. However, if they haven't got a position in the queue, we then need to make a space in the queue for them. And the way that we do that is just by incrementing the length of the queue by 1. And this will return the new length of the queue. And we can know that, you know, because we've just added a user to the queue and this operation is atomic, that the value returned by this will be the user's new position. So once we've determined what their position should be, we sign that in a token. This is the reverse operation of what we just did, with our secret that also comes from the Edge dictionary. And then we can do a really, really basic calculation to work out if the request should be permitted, which is simply if the current, if we are far enough through the queue that the current queue cursor is larger or equal to the visitor's current position, then the request should be allowed. They've waited in the queue for long enough, they're permitted. If they're not permitted, this is where we have a bit of magic that works to automatically let people in, and we'll come back to this shortly. I'm just going to skip forward for the sake of showing the full flow. So if the user is not permitted and we haven't automatically let them in using this code up here, then we're going to send this request to a function we've created called handle unauthorized request. And what this function is responsible for is just rendering a page to the user that explains to them that they are currently in a queue and shows them how many people are waiting ahead of them. And we've done this really, really simply by creating a process view function that reads the given view and uses a regular expression to substitute the values that you've provided dynamically. Now, once again, in a production environment, we would suggest that you use a templating engine, something like handlebars. But you know, for the purpose of a demo, I think this is perfectly suitable. So yeah, if the user is not allowed in, we will send them a 401 forbidden HTTP status, and we will you know, substitute the values on the page. And what they'll receive is a page like this that says, sometimes we have to restrict the number of people who can access our website at the same time. There are 3 visitors ahead of you. And it's worth noting as well that we have a meta tag in the header here. And this is responsible for making the browser refresh the queue page typically every 5 seconds, so that this counter will slowly reduce. And as the visitor is allowed in, they don't need to refresh the page, because once they refresh and the request is permitted, it will be forwarded to the backend. Which takes me on to the second option, which is handle authorized request. So if the request is permitted, we simply pass it to this function, which will forward the request to the content backend. So this content backend you could think of as your application, your content management system, whatever it is that you're trying to shield with a queue. So once the user's made it through the queue, this service is essentially transparent to the user, because we will just forward all of their requests to the backend. So that's happening here. This is where we're making the decision and then calling the right function. And finally, if we have decided that the user needs a new position and we've written that token, then we need to manipulate the response that we've received earlier to just add the header, add the cookie to the HTTP headers. And finally, we will log our any data about the request to a Fastly log endpoint. This is something we don't particularly have the time to get into now, but Fastly log endpoints let you aggregate log data and send it to one of many log providers that we support, including your own if you just want to receive it over HTTP. So this is a fantastic way to gather analytics about the way that the queue is operating. You can use this with a tool like New Relic to generate a dashboard. And in fact, if I go to our GitHub repository, you'll see exactly that in the README. Okay, now I've just made a fool out of myself because it's not in the README. However, this is the result of our handle unauthorized request queuing page. Right, okay.
So
that was information overload. I apologize. Jenny, is there anything that you think I should clarify before we go on to deploy this?
I think just to get the sort of basic structure down. So let's say I'm trying to buy Coachella tickets and there's 99 people in the queue. So when I join, I'm user 100. And the cursor is at, say, I don't know, 95. So 95 people have been let in before me, and I'm 100. So once the cursor increments up to 101, then it'll be safe for me to go get my Coachella tickets. Is that right?
Absolutely, yeah. So your position 100, the queue cursor is 101. So based on our very simple comparison right here, yes, you would be permitted. And because your request was permitted, it would be passed over to handle authorized request.
Cool. So yeah, it's I know that was like a lot of code, but at its core, it's a pretty basic process of just doing some simple arithmetic to decide who gets in and who doesn't. So yeah, how can we expand on this?
Sure. So you know, I think this is probably the right time to talk about our automatic mode. So on Computer Edge currently, you cannot run a cron job. This may be something you're used to, where you can schedule an operation to run perhaps every 15 seconds. However, because this endpoint we know is being hit pretty regularly, and we have an atomic counter, what we can do is something a little bit smart, which is where we generate a key within Redis based on the current time. So we actually divide the time, the current Unix timestamp, and round it down to the latest, by default, 15-second period. We then try to increment a counter within upstash using that period as the key. And what we know is that if this operation returns 1, then nobody has made a request within the past 15 seconds because you know, this would have been incremented already. So based on that knowledge, we can say, you know, if the requests in this period are 1, i.e. this is the first request, then we can actually automatically let some people in because this is a trusted client. So what we do is, I've seen the question in chat, I will definitely address that afterwards. We will see if the queue is behind, as in there are enough people waiting to be let in. And if that is the case, then we will let in a configured amount of people, which by default is 5. And you know, letting people in, the operation is literally just incrementing the queue cursor within Redis. We also take the new queue cursor after it's been incremented to recalculate whether this request is permitted based on the change that has just been made. Leon in chat asked, what about resetting a queue / cursor / positions? Customers can't keep a certain position forever. That's a very good point. They cannot. However, we do include an expiry within the payload, which by default, I believe is, 1 day. So after a day, the user will have to wait in the queue again. This could be improved by perhaps reissuing the token regularly, because if you have a user who is actively using your site for 24 hours, you don't want to kick them off at the end. But yeah, no, that's a really good point. And I think I would echo that this is very much a starter, and for a production implementation, you would want to think about those things. And we actually have some next steps in our README that explain those kind of things that you would want to think about. But thank you for the question, and really nice to see you here as well, Mr. Fastly. So, yeah, Mr. Fastly, well, I've heard that Leon is very vocal within his organization about how great Fastly is, and we really love to hear that.
Oh, we appreciate that. Thank you, Leon.
So, okay, where were we? We were looking at the automatic queue implementation, and this allows people to be let in automatically, rather than having someone on the back end clicking a button to let 5 people in every few seconds. Now that it's explained, I think the best thing we could do here is actually deploy the application and see it working. So let's go through all of the steps required to do that. How are we doing on time? Not too bad.
I think we're doing good.
Cool. Let's sign up for Fastly.
Let's do it.
So if you didn't know, Computer Edge has a free trial, so you can just sign up straight away. There you go, everyone can have my phone number. And we'll just come up with one password. Looks like we are actually somewhat sensible. Apparently my password is a dictionary word. I've never heard that word in the dictionary. Let's generate something.
What did you put in?
It's a password I've used for many years, and it's certainly not a word. But yeah, sure. I am just going to pull up
my config store somewhere.
I hope not. I'm just going to verify this account. It should take 2 moments, but I would rather not share my email with everyone. Fantastic. Let's sign in. Obviously, at this stage, I would recommend that everyone sets up 2-factor auth. However, I'm not going to make you sit through that, because that won't be too exciting. Okay, so we're in. There's one last step we have to do in the web interface before we can close it entirely, which is generating an API token. For the sake of this demo, I'm going to have to show everyone the token. Here you go, enjoy. But this account will be deleted after the stream. So I suppose if you want to go wild, then you can.
No funny business, please.
We're going to create a user token, which represents me as a user on this account. However, if you had multiple services on an account and multiple users, you'd typically want to generate an automation token, which isn't tied to any specific person on your account. And we're going to give it global API access because we want to create a new service. Typically, if you were generating a token to just work with one service, you would limit it to that service. But in this case, we can go global. And it's always good practice to have an expiry date as well. Right, there's the token. Let's go ahead and pop it into our Fastly CLI. using Fastly profile create. I just need to delete my existing profile first. Nope. Okay, cool. So we now have a fresh installation of the CLI. I'm going to run Fastly profile create, and it's going to ask me for an API token. So I will just paste in the token that I got, and straight away, there we go, we're logged in. I'm also going to update the CLI because I don't want you to have to read that every time. And we can verify that the token works by either saying Fastly service list, which in our case should be no services because we just created the account, or Fastly who am I, which will bring the information that we've just filled in on the web UI.
Kind of existential.
So just to quickly run back through how we started this, we pulled down the starter kit by using Fastly compute init. We haven't actually changed any of the code. I just walked through it. So after running Fastly compute init, we're going to simply run Fastly compute publish. It's going to compile our application into a WASM binary that's ready to upload to the Fastly API. And technical difficulties here.
Webpack.
Webpack is the bane of my life. Let's just check that we're on the correct node version. And we'll go ahead and run.
npm install.
Yeah, npm install. Yeah. Thanks, Mark. If anyone doesn't know Mark, he is our fantastic CLI developer, and we're really honored to have someone that's as dedicated as him.
Yeah, thanks, Mark.
So it's worth mentioning that at Fastly, we don't see your source code. You actually upload a pre-compiled WebAssembly binary to our API, and we execute that. And we basically define a set of interfaces that your application can talk to. And our default SDKs, such as our Rust, JavaScript, and Go SDKs, provide language-specific idiomatic interfaces on top of these raw host calls, they're called. So for that reason, we need to, as part of the JavaScript build process, actually package your whole application into one JavaScript file, which is what we're using Webpack here for. And we also have to bundle it in with a copy of the JavaScript engine, SpiderMonkey. And the result of that is that you get a fully self-executing WebAssembly binary that will run your JavaScript. I do apologize for the wait here. I think my computer was not built for streaming and zooming and coding at the same time. While we're waiting for this, does anyone have any questions in chat or just want to talk about their weekend plans? We're very friendly people.
Yes, we're friendly. What are you doing this weekend, Kailan? We have a wellness day tomorrow.
That's a really good question. I think tomorrow I'm probably just going to sleep a lot. As for the rest of the weekend, I'm sure I have events planned with friends. You know, I like to ride my electric skateboards, so I'm sure we'll do a little ride around London. Yeah, mainly a bit of rest and recovery, I think. What about yourself?
My friend's having a birthday party at Magic Mountain, which is a Six Flags, not resort, Six Flags amusement park here. So we're just gonna ride a bunch of roller coasters and eat a lot of funnel cake and try to win some rigged games. It's gonna be a good time.
That sounds fantastic. I'm a bit jealous, actually. Okay, so npm install has run. Webpack has run as well as part of the build process. And then the Fastly CLI has taken the output of those and packaged them into a tarball, which is ready to be uploaded to the Fastly API. Now, before we can upload it, one of the things that's required is that we actually create a service. And the CLI knows that we haven't done this yet, so it's going to walk us through the entire process. As Jen points out, yes, theme parks do have queues. I'm going to accept the defaults for this service. including the domain name that we host it at, although you're always welcome to customize this. As for the content that we're actually protecting, I believe Journie has put together a glitch application that we can use for this, and that is this one. If you don't know Glitch, you definitely should. It is the place to experiment with building JavaScript applications and perhaps in the future even computer edge applications. It is obviously operated by Fastly, but the team there are very, very dedicated people, and we're really, really lucky to have them with us.
We love Glitch. If you are a creative coder, definitely check out Glitch because there's so much cool stuff there. You don't even have to code anything. You can just go on there and look at what's been built and get inspired. There's a bunch of really cool stuff on Glitch, and it's so easy to just build something and deploy like right away. So I love Glitch. It's a really great way to do some prototyping.
Okay, so Journie has even designed a really cool looking queue page. So later in the stream, we will customize the one that is included with the starter kit to look like this. But actually, I think what's important to us is /inside. Now, you can imagine that this is the content that we're trying to protect. This could be a shop front for selling tickets for an event. You know, we need to protect this by making sure that there aren't too many users on it at once. So we're going to set this up as our protected content backend. I guess I should look at Mark messaging me. Warning, bug.
What did Mark say?
While I wait to find out what that bug is, we'll carry on configuring this. So we pop the host name into the Fastly CLI. We also want to specify the port. Since this is being served over HTTPS, which Glitch lovingly configured for us automatically, we will use 443. On top of that, we also need to configure our Upstash service. So let's go ahead and sign up for Upstash and pop those details into the CLI as well. I see. Thank you, Mark. I don't think that will be an issue, but I will keep an eye out. So Upstash sign-up is ridiculously easy in that you can just sign in with your GitHub account. I imagine that's what most developers will want to do, so that's what I'll do here. As soon as you're signed in, it will walk you through a process to create your first database. It's incredibly straightforward, but for the purposes of this tutorial, I'll just use the one that I already have. Once again, you're probably likely to see my token here, so I'd appreciate if you don't do anything with it, but there is nothing in this database, so yeah. You go wild. The important piece of information here is the REST URL, but we actually don't want to configure the full URL within the service. We just want to configure the host of the backend. So we'll copy that and we'll configure that as the host name for our Upstash backend. Once again, this is SSL, so we'll do it on port 443. Okay, and now there's only a couple things left to configure. We need a secret to use for signing our JWTs. This should be randomly generated, but for the purposes of a tutorial, it can be ABC123. And finally, we need a token for our Upstash, which we can grab from the panel right there, paste it in, lovely. And also, in order for us to be able to construct the request, we do need the full URL as well. So we'll paste that in. All of those parameters that we've just provided, they will get added to an Edge dictionary using the Fastly API. And then the application will be able to query those later on by calling dictionary.get, as you saw earlier. Oh, Mark was right, actually. This domain is taken. So let's provide our own domain. I may have to quickly pop those parameters back in. Okay, while I reinitialize the service doing exactly what I just did, Journey, would you mind just plugging the socials briefly?
Yeah, my social is right beneath me. Kaylin's social is on top of me. And we're also on Twitter as Fastly Devs, not our individual Twitters. I'll post a link to that in the chat. And I'll also post a link to our developer hub once again. And the crown jewel of DevRel at Fastly.
It sure is. We love our developer hub.
Yeah, not to diminish all of the other work that we do.
Okay, we have created a domain.
Fastly and Glitch are hiring. That's true. Should I plug our?
Certainly should, especially because I've done something wrong again, so I'm gonna have to have to try again.
Yeah, the Glitch team is hiring. There's some really great people on the Glitch team. So if you want to hang out with some very cool people, you should check out that Glitch job posting.
We need new faces. Definitely take a look.
Mhm.
We're almost there.
Thank you for your patience.
It's funny actually because the issue that we just showed has been fixed today. It just has not yet been shipped into a new CLI version. So great work, Mark. There, we will definitely. As a user, you will not experience that.
Thank you, Mark, for the bug warning. Warning bug is a
Warning bug. Yes.
very funny.
I wasn't sure if he had potentially spotted a bug in our code, in the glitch.
In your room?
Oh, I didn't even consider that. Okay, we are almost there, people. Just popping the upstash token back in, and I suppose I'll share my screen again. Nothing to hide. The upstash URL. Okay, so here we go. The CLI is creating all of the resources. It's doing it very quickly.
Fastly, even.
Absolutely. And it's uploaded the package and it's now activating it. So very, very shortly, we should see that our queue is live. In the meantime, I will just head over to the dashboard and show you what it looks like now that we've initialized all of these resources. Let's just bring it up onto the screen. Cool, so this is our service within the Fastly dashboard, and you can see that it's got one version. That's the very first version that we have uploaded. Can we join the queue? Oh yes, you absolutely can. Well, I tell you what, let's try and get as many people in the queue as possible in a moment. I think that'll be fun.
Yeah.
But yeah, there's a few resources attached to this service, one of which is a domain. Edged compute.app domains automatically have TLS configured, so you can just come up with any old subdomain and it will work. However, of course, you can put your own domain in here, and then over in the secure dashboard, you can configure TLS for that domain using Let's Encrypt or a commercial CA. Earlier, I mentioned backends, which are a requirement for Fastly services. So these are the two backends that we've defined, and you'll have seen that we were prompted for these. So this is our protected content backend, which is configured with TLS pointing to Journie's glitch app. And this is the upstash backend, which is also configured with TLS pointing to the upstash instance that we just created. There's one more thing to take a look at, which is the edge dictionary, the config edge dictionary. So here is the secret that we came up with. Here is my upstash token, and here is my upstash URL. This all looks configured correctly, so I believe we can go to the queue. And there we go, 24 people ahead of us in the queue already. You
Oh my
guys
gosh.
have absolutely smashed it. So yeah, the queue should be in automatic mode by default. So you'll notice that this has just gone down from 24 to 19. And in fact, I'm also just going to go to the right path so that we can see Journie's page when we're done. If we give this about a minute, we'll see that the queue slowly tapers down to 0 people waiting. And at that point, I will end up in the club, essentially. In the meantime, I will pull up another great computer edge feature, which is Fastly Log Tail. And this will give you a live stream of the logs coming from the service without the need to configure a logging endpoint. Although I have just come to the realization that we have configured a logging endpoint for this, so we're not going to see anything in the output. A great way to demonstrate that this is working would be to just replace the log statement here with the standard JavaScript console.log, and at that point you would see the output in Fastly Log Tail. And yeah, look, we made it through the queue. We're in the club.
Yay.
We've got our rave tunes. I never thought it would be that straightforward.
Yeah, you don't have, this is nice. The virtual queue is nice because you don't have to worry about whether you're wearing the right outfit or if the bouncer is going to let you in or if you're caught speaking English in line. You know, all you have to do is wait.
Fantastic. So as you can see, the queue does work as intended. If I were to now open this in an incognito window, and you'll see I'm now, wow, 104. There's someone there just spamming it, clearly. But yeah, I mean, unless I've made it through the queue, my requests aren't going to be sent to the backend. So the backend is essentially protected. But there could be an issue in that the operations that we do on the website once we finally get in are intensive. We don't want to keep letting people into the website every 15 seconds if it can't keep up with what's already there. So this is where we're going to actually live code some new functionality and try to improve this to be more production ready. And the way that we're going to do that is by building an endpoint within our application that already exists that will serve the current CPU load of the backend as a number. So if I go to journeys-app.glitch.me/load, I would receive a number like 0.2. And then we can use the data from that endpoint within the queue application to say, well, if the queue is, if the load is larger than 0.8, then we probably shouldn't let people in yet. You know, this is really simple, obviously, but it shows how quick and easy it is to make these kind of changes to our starter kits and integrate it with your existing infrastructure. So let's get started with that. Let me just pull up the relevant applications.
Alex says, if you close tab and reopen it, you keep your place in queue. Has its pros and cons. Yeah, I guess that's good. If I were to accidentally close the tab, I wouldn't lose my spot in line. And that is a risk for me because I have like a million tabs open at all times. So my tabs are really tiny and sometimes I do miss my targets. But what would be the cons?
The cons of maintaining the state through sessions. I suppose it's a bit different to queuing for something in real life, because if you leave the queue, you can't expect to just come back 20 minutes later and stand in the same position. So no. Yeah, that's understandable. But the beauty of this is because it's a starter kit, which is just a JavaScript computer edge project, nothing special about it. If you wanted people to lose their position after leaving the page, you could certainly do that.
Yeah, there's a lot of ways you could build on this. I've been in situations where the queue is random, so it actually doesn't matter what time you join the queue, you'll just get put in some random spot. That's maybe a little bit more equitable, so that way, you know, everyone gets at least an equal chance of getting a good or bad spot in the queue, no matter what time they join the queue.
Absolutely. Right, okay, cool. So I'm going to show the first step of this whole implementation, which is that we need to build the endpoint to report the CPU usage. So right now I'm just SSH'd into a random virtual machine on Google Cloud. And within this we have Journie's application, but we've made a slight change to it in that we've added this helper function, which was shamelessly ripped from Stack Overflow. And this will return the magic number that we're looking for. It will actually return an idle and a total number. And we're going to register a route within the application when I find where it was. So when we receive a request for the load endpoint, we're going to start measuring the CPU usage. Then 100 milliseconds later, we're going to take another measurement. We'll do a little bit of maths just to work out the average over that period of time. And we return the full representation of the server's load as just a percentage, as I described earlier. This is incredibly simple, as you can see, but if I run it on the server and briefly try to find the IP address of that server so I can curl it. 2 moments. Okay, cool, I've got it. We'll just do a simple curl. Oh, it's on port 8003. Oh, it's always great when... Oh, I'm so silly. That is an internal IP address. I was just testing everyone to make sure everyone was paying attention. That's more like it. Okay, so we've received our 0 because the server's not currently stressed. And to demonstrate that this is accurate, let's just stress the server a bit. We'll just stress one of the CPUs, and then we'll run the same request, and we can now see we're at 100% CPU usage. So obviously, at this point, we don't want to be letting more people in to the queue. So let's modify the queue starter kit to take this into account when making its decision whether to let people in.
Let's do it.
Okay, so let's think about where we're going to actually slot this into the application. It's worth noting that we don't need to change much. However, we are obviously going to need to point the protected content backend at this new server. So let's go on to the Fastly admin panel and do that right now. When working with computer edge services or even our VCL delivery services, we base them on versions. So the way that you would ship new changes is by cloning an existing version, making changes to that newly created draft, and then publishing that draft once you're done with it. All that we're going to be doing here is updating the backend so that rather than going to glitch, we are going to our brand new backend in Google Cloud. The only reason we're not using glitch here is that I don't want to DDoS glitch to demonstrate that we can stress it. I don't think that is very sensible, and I don't think that they would like us as much if we did that.
Yeah, we have a good thing going. We don't want to mess it up.
Definitely. Jen's trying to figure out how to jump the line to get Beyonce tickets. That's a secret, unfortunately.
Yeah, we can't. Our lawyers have advised us to not tell you how to do that.
Also, if we told you, then maybe you would grab the tickets that we would have. So
yeah, I'm trying to get those tickets too.
Let's also just take a quick look at what this site is serving as its main. Okay, it's just going to be an internal server error. Okay, so when we have this working successfully, we will know it's working when we see a 500, which is an interesting way to do a demo, but we'll keep you updated along the way. So we've updated the service to now point to the protected content backend at the new address, and we can verify that by refreshing the application. At which point we would expect to receive something different than this. It's just cached. So obviously as a CDN, one of our main things that we do is cache content. So we are still receiving an old version of the page. We could of course send a purge request to this service so that we don't, but for the sake of this, I think we can just use a different path. It's worth mentioning as well that because we're an authorized user, as in we've already gone through the queue, we can make a request like /load and it gets passed to the backend as we'd expect. So we know that we can get that info from the backend, so let's do it programmatically. And the right place to do this is right here where we decide to run the automatic checks. So there's no point in doing this for every single request. So we'll only fetch this load if this is the first request within the first period. So we'll just throw some code in here. The load response would be it doesn't matter what host we use. And we'll also pass a backend parameter, which is required. And we'll also provide a TTL of 5, just so that if for any reason we do call this more than once every 5 seconds, we will get a cached response. This is a standard JavaScript response type. So what we can do with it is just get the body, so get the text, and we'll also pass it into a float. Although I think actually in this case it's an integer, right? It's 0 through 100. So we'll pass the integer. And for now, let's just log that and see if it works. So once again, we'll go into our terminal, we'll run fastly compute publish. We won't have to do all of the things we did before because we already have a service set up now. Apologies. I ought to have put an nvm rc file in this directory.
There's a card game called Bird 9. Oh, I have to know about this. Wow, it looks cool. Thank you for telling us about this, Dora.
That'll have to be something for the next team summit.
Yeah.
You may think that this activating version step is taking a long time, but when you consider that it's actually pushing out your compiled code to every Fastly pop in the world, it's actually pretty reasonable in my opinion. And now we're going to just load up the queue in an incognito tab, as well as Fastly log tailing. Two moments, I'm just trying to organize my windows a bit. Fastly log tail, and we would expect that this would start outputting the load numbers. Of course, only if this is coming from an unauthorized user. There we go, load 0. So we can see that the computer edge application is receiving data from our backend, and if we stress the backend, then we will also see that the load goes up on the next request at the very least. I should probably stress it for a bit longer. Oh, that's not good. Okay, we're inside. We're missing some CSS, but we are inside.
-1 people ahead of us in the queue.
Yeah, that's a little concerning.
We did it.
Just to verify that this is working as expected, I'm going to just do this again, but stressing the server for a longer period of time. So actually, it seems like it's not working. I'm going to say that this is down to the way that we are passing this body. I think it comes with a percentage symbol at the end, potentially. Let me just verify that. Oh, it does not. Okay. So let's just do a bit more debugging. And perhaps it's worth mentioning at this point that actually to save some time here, we could configure the local server to point at our backend. And this would allow us to test without having to deploy to Fastly every time. So I think I'll do that to save everyone a bit of time here. Oh. Oh, silly me. Cool. So now rather than deploying to Fastly every single time and depending on log tailing, we can actually just run Fastly compute serve. What we do here is actually run the WASM binary in the same way that we would on our edge network, except we're using our open source runtime, Viceroy. And of course, every time I open a new terminal, I will have to do this. But what this means is if you're curious about the way that Computer Edge works, you can definitely poke around the Fastly Viceroy repository and see an open source implementation of it. It's really exciting. Okay, running local server. We'll just wait for that to come online. I do apologize that my CPU is struggling so much. You may even be able to hear it going whoosh.
I don't hear it.
Oh,
but
good.
I believe you.
I think that's because half of the effort it's putting in is actually to do noise cancellation.
Oh, nice.
Okay. And one last thing is we need to update the configuration. So obviously earlier when we deployed to Fastly, we set up an Edge dictionary and configured all of our values within the API. The alternative to this when you're running the local server is that you specify a dictionary file, for example, devconfig.example.json, but in our case, we're going to remove example, and we're going to make this match our actual configuration, which is, if I go back to Upstash, nope. The beauty of live programming. We need the URL. We need the token. That's not the token. That's the token. And while we're at it, I'm just going to ensure that the backend configuration within the Fastly toml matches, which it does.
Hooray.
Now if we run Fastly compute serve, we should not receive an unauthorized error from Upstash. Realistically, I think we're probably going to be working on this for about 15 more minutes. I would love it if you could all stick around. However, I do understand that we scheduled this for 1 hour only. Too many tabs.
I feel you.
Okay, cool. So the server is running. Let's go ahead and click on the link. And we have an error. Connection refused. Got it. My bad.
The port.
Yes, very important. Important? Thanks, Monkey Middle, for the kind message in the chat. You guys have all been so fantastic, actually, that this hasn't been very stressful. This is really enjoyable, and I look forward to doing more in the future.
Yeah, our first stream. This is so exciting.
Not too bad. And you know, we have had a few issues, but I think that just demonstrates the beauty of programming. No one in real life works on a project without coming across a few bugs along the way, so we really appreciate you sticking around.
Plus, hopefully, showing off all our bugs will help you avoid them if you decide to implement this yourself.
Okay, so we are getting a response from our local testing server. Let's just reorganize some windows so that you can see everything. And we would hope to see the load being printed at some point here. Yeah, okay, cool, 100. So that's correct. It is parsing correctly. That's interesting. I wonder why that didn't happen in production. It's probably down to the fact that we are caching the response from the backend, right? So let's actually take this TTL to 0, and I think we can enforce that the request passes the cache. Yeah, okay, that's correct. Cool. So let's try again in production this time, but you know, without hitting the cache when we request the load.
Cache rules everything around me.
It sure does. Cache is king at Fastly. We should get some merch, actually. Cache is king. CHE.
I think we are working on that merch.
Oh, okay, great.
I think we're getting stickers.
Even better. Okay. We're almost there, people. I wonder if YouTube lets us edit this down a bit afterwards so we can cut out all of the bits that didn't go so well.
Should we cut those out? I feel like they're valuable learning opportunities.
It's a very good point, actually.
Fiddle around and find out merch. That's a great idea.
That's fantastic. Someone needs to tell Andrew about that ASAP. Although I'm sure he's heard it. Okay, so we will once again hit this from an incognito window so that we are not in the queue, or sorry, are in the queue. Cool, load is 0. But actually we would expect it to be 100 at this point. That's really interesting. Okay, so we do have an example of this working in production. I'm not quite sure why this isn't, but for the sake of getting this finished, we'll continue to code using the local testing server. So we've got the current load. And actually, there's only one really, really simple part left, which is to just compare it to what we would expect it to be. So let's go into the config and set a new parameter so that we can change this. The maximum load of the backend server before visitors will be let in. Integer from 0 to 100, maximum backend load. And let's say if it's above 75, then we should hold off on letting users in. Then all we need to do is compare the current load to see if it's bigger than equal to the maximum backend load. Or actually, we should probably do this the other way around. So if the maximum is larger than the current load, then we will let some people in. So let's just move that code into this block. Fantastic, and let's run it and see what happens. We'll keep the logging in so that we can get a bit of visibility into what's going on. We're on the home stretch now.
We're almost there. I've heard that in the UK, queuing is very popular. Like it's almost a pastime over there. Is that true?
Yeah, it's a bit, I want to say it's a stereotype, but I think actually it's very true. I'm sure you would have seen when the Queen passed away last year, we had this absolutely monumental queue going through the city, and I had the pleasure of walking past it a few times, and you know, for days on end, there were just people stood in the same position. It was incredible.
I heard there was a queue to get into the queue.
Yeah, and I think there's probably another one on top of that. Yeah, very, very interesting few weeks that was. Sorry, I keep opening tabs in the wrong window. Okay, so let's open this in an incognito one so that we can be in the queue. Yep, silly me, deleted too much code. In my defense, it is 8 p.m.
Well, the nice thing about programming is it's very fast. When you break things quickly, you can also fix them very quickly.
Yeah,
Nice.
absolutely. I think this would be very different without the local testing server. It's really useful to be able to, because obviously our production network is fast, but it's fast deploying globally. Whereas when you just want to test one thing on one machine, it does make sense to emulate it. And it also has a lot of really useful debugging tools as well. So let's see, the load is 100. So as this page refreshes, we should see actually that no one is getting let in. The queue is staying at the same length. And that does appear to be the case. We'll just let that go a few more times just to verify that. Cool, okay. Now let's stop stressing the server. Command C, or Control C even, and yeah, there we go. People are being let in. So we've demonstrated that we have a queue that was already working, but didn't have any kind of feedback loop. We've introduced a feedback loop by reporting the load from the backend and using that when we make a decision about letting people in. The only thing that's missing is we haven't deployed the fully finished solution to Fasty's production network due to some kind of bug in our code. This isn't an issue with Computer Edge. I clearly have just overlooked something, but we've had this working in the past, and obviously as a customer, if you were to have any issues with this solution, then we would be assisting you with it. But yeah, I think that's all from me. Journey, did you want to wrap things up?
Yeah, so we covered a lot today. We talked about how to build a queuing solution by just doing some simple arithmetic, calculating how many people are in the line, what's your position in the line, and how many people have already been let in, and subtracting your position from the queue cursor. And then we talked about how to build on top of our starter kit that we offer to modify this any number of ways. In this way, we're talking about making it so that you can only be let in provided that your server isn't super stressed out. But there's a lot of ways you could modify this. We talked about you could maybe make the queue positions random. You can make it so that you can reset your queue position. Yeah, so I definitely encourage you all to check out this starter kit and our bunch of other starter kits that we have on the Developer Hub, which I will plug one more time. Always be plugging. That's what I say. Um,
We
and
also, sorry to interrupt you, we also
yeah,
do
go for
have
it.
a blog post about this exact solution. So if you're interested in learning more about how it works, or you just weren't sure the way that I explained it, then check out the blog post. It also ends with a few ways that you could customize it further. So lots of inspiration there.
Yeah, and so be sure to like and subscribe and turn on the notification bell for more Fastly Devs content. We have a lot of fun stuff planned for the rest of this year and beyond. And thank you so much for joining us for our first stream. This has been great. Thank you, Kailan, and thank you all. And have a good day.
Thanks, everyone. We'll see you all soon. Bye bye.
Bye. See you on the edge.